Greetings, welcome to APchemistrycourse course, and today's lesson we're going to talk about the ideal gas law. Ideal gas law. It was discovered in 1834 by a French scientist called René Capiron. So, the scientist made that formula called P times V equals N times R times T. Alright, what is that formula? This formula includes all the needed units in gases, including pressure, volume, and the moles, number of moles, and R, which is the constant unit, and temperature. All of those combined together making the ideal gas law. So, this formula talks about everything that we need to know about gases. And let's put it all in one image. Let's take an example of a tire. Having pressure due to air particles, we can notice that air particles are always in constant random motion, colliding within each other and within the containers of the walls, and we won't have that motion pressure, so we have pressure due to that. Alright, so another thing, volume. We have the volume, we have here an increased volume from the original volume. You can see this is, for example, the tire before, and this is after, and we can notice that we have a increased volume, and we can have a decreased volume, increased volume, depends. Then we have the number of moles. So what is that? It's the number of particles or air particles that are inside the tire. Could be anything other than a tire. Anyway, we're going to have now T, temperature. Now, the temperatures of the tire can vary. We can also control the temperature of the tire. I can increase now, put some heat source, and just heat that tire, and it will just increase in heat or in temperature. So, different variables play different roles on the idea, and we can notice that including all of them, we're going to have a almost perfect idea of how a gas will behave. Of course, not all gases are ideal. As we said, that no gas can be a perfect gas, applying all the rules of the kinetic molecular theory of gas, and also that in this formula it's going to help us understand how can gases act. Alright, so let's start. As you can know, this is an introduction, so let's start with a small example. A sample of helium gas at STP occupies 70 liters. Determine the number of moles of helium. Let's start simple. As I always say, write down the units given. So, the units that are given, a sample of helium gas at STP. That's the first unit. We'll talk about it later. Occupies 70 liters. Determine the number of moles. Number of moles is the number that should be known. Alright, so let's write down the givens. Number 1, pressure. For the pressure, it's a common clue that was given by the text that STP stands for simply standard temperature and pressure. What are the standard temperature and pressure? You're right, 0 Celsius. And the pressure is going to be 1 atmospheric. So 1 atm. So let's start with the pressure. Pressure is going to be 1 atm. Let's write that down. 1 atm. Then we're going to go with the other unit, V, volume. So then it mentions that it occupies 70 liters. That means this is the volume. Next, we got this. Number of moles. Number of moles. Determine the number of moles. So, it's just the unknown value. Alright, next, R. What is the story behind R? We're going to talk about it right now. Next, T. We are going to have now T. So, T is given as standard temperature, which is going to be 0 Celsius. Now, 0 Celsius isn't accepted in chemistry, especially in ideal gas or in the gases. We need to convert any Celsius unit into Kelvin. So, the unit of temperature must be Kelvin, no matter what. So, in order to do so, we need to add 273.15 added to the number of Celsius to get the Kelvin. So 0 is going to be placed right over here, so the number is going to be simply 273.15. Alright, Kelvins. Let's put the unit. So, we got everything. What about the R? What's the story behind R? We said that P is pressure, V is volume, N is the moles, R is a constant number. Alright, so it's a constant number, and T is the temperature. What about it? So this constant number can be used always in the ideal gas law. It can differ depending on the units that are given. But for now, we're going to talk about it when the units include liters, ATM, moles, and Kelvin. And here's moles. So we have the givens here. Now, from that we can get the number of R as this. R will equal to 0.0821 multiplied by liters times pressure. Latin. I always like to call it Latin. Alright, that's great. What about the others? Then we are going to have down as Kelvin temperature, and we're going to have also the other unit, which is going to be simply number of moles. So it's going to be N. Great. So number of moles, let's just write down moles, because it must be written. So that's the R. So now we have R having the values that are given, the ATM and the L. We can just use this 0.0821 for now. Of course, in a couple of videos, I think after 2 videos, after that video, I'm going to upload another video. After, I'm going to make a video about R, and we'll talk about different types of R's and what's the story behind R, and why is it really important to the formula. It's really nice, and you'll understand why is that bizarre number being used. It's really helpful for us in chemistry. Well, let's go ahead and plug in the value. It's going to be 0.0821 and so on. We have the unit. Alright, so let's start solving the question right now. Now the question has P times V equals nRT. Number one situation, or number one clue that we can use, that we can just apply for this situation, is rearranging everything by the variables itself before plugging in any value. Alright, so what is unknown is N. So the N is unknown. We want it right now. In order to know what is it, we need to keep it in one side of the equation. Now in order to do so, what are we going to do is simply write N equals P times V over R times T. Alright, so let's do that. Or let's do this real quick. Let's start solving. So, N, we're going to have the first value P, which is going to be 1 ATM above 1 ATM, multiplied by the V, which is 70 liters. 70 liters. Now the R. Before we put the R, let's plug in the T, which is going to be 273.15 Kelvin. Put a multiplication sign, and we're going to put we're going to have the R down there, so it's going to be 0.0821, and we're going to have the Kelvin units up, moles up, the mole up, and here multiplied by the L times ATM, Latin. Alright, so why did we do that? In order just to cancel units. So this goes with this goes with this, Kelvin goes with Kelvin, we're left with mole. Now let's do the math. What's good about that is that we knew that we're searching for something right, which is the moles. So let's start doing the math, and let's do it in the calculator real quick, and let's solve it. So we put down in the calculator 1 times 70 over 273.15, then we multiply that by, we'll put 1 above, and down we're going to put 0. Oh, you know what, just a second, we're going to have it like this, we're going to have this multiplied by 0.0821, yeah, did I put the 821 here? So let me put the 1 here, 821. So 0.0821, and we're going to calculate it. The number that we are going to get is 3.12 moles of helium. So this is the answer that we got. So N equals to 3.12 moles of helium. That's really great, really simple, and this is the idea of ideal gas law, PV equals nRT. Alright, so this is simply the idea. Let's put a quick recap. Then it talks about the mixture between pressure, volume, number of moles, and the constant unit of R, and multiplied by temperature. It talks about how can we just solve everything with all given values. So this is all about our lesson for today, and I hope it is useful. So don't forget to watch the gas law playlist, and new playlists are coming along, including writing formulas, naming formulas, common mistakes, Vesper, and so on. So this is all about our lesson for today, and I hope it was useful. Have a nice day.